Alrighty, folks. Sound intensity. Okay, another application of logarithms. The intensity or the loudness of sound is another physical phenomenon that has a large range of values and is therefore measured using a logarithmic scale. So when you ever hear the word decibel, I'm sure we all have, right? We say certain decibel noise, or you go to a rock concert, or background noise, or what is the threshold of human hearing, like we can barely hear, like a whisper, or what's hurtful to the ear, right? So this is all measured in decibels. Here's the formula. dB, the decibel value, equals 10 log of I divided by I naught, where dB is the intensity of sound measured, and I divided by I naught is the intensity ratio between the intensity of the sound that you're measuring compared to the threshold of hearing, the level at which humans can't hear noise. So again, similar to the Richter scale, it's comparing two sound intensities, a reference sound intensity, the threshold of hearing, and whatever you're measuring. The most common unit, let's talk units, of measure is the decibel, which is equal to 1/10 of a bell. That sounds familiar if you remember I think the inventor of the telephone, Alexander Graham Bell. Well, they named this tone or the unit after him. Okay, on the Bell scale, like the Richter scale, a difference of 1 bell or 10 decibels. So this deci part means 1/10, right? So 1 bell is 1/10. 1 decibel is 1/10 of a bell, so that's why 10 decibels is 1 bell. Okay. A difference of 1 bell or 10 decibels corresponds to a tenfold difference in sound intensity. So a leaf rustling right here, that's 10 decibels. A leaf rustling is blank times as loud as the threshold of hearing, where here's the threshold of hearing at 0. So that's 10 times as loud as the threshold of hearing. A whisper, that's 30 decibels, is how many times as loud as leaf rustling? So there's a 20 decibel difference, or a 2 bell difference. That's going to be 100 times. Okay, like 10 squared, right? 2 units of 10 fold. A whisper is blank times as loud as a conversation. So I started a whisper. Here's my conversation at 60. Okay, what's that difference? Well, this now is 30 decibel difference, or 10 to the third difference, right? But we're comparing a whisper, something quieter or less intense in sound, compared to conversation. So instead of being 1,000 times, it's 1,000 times as loud as a conversation. So this would be 10 to the negative third. Okay. A tractor has a sound intensity that is 10 to the 5.5 times more intense than the threshold of hearing. What is its sound intensity measured in decibels? Let's use our formula. Decibels equals 10 log of I over I over I naught. So 10 to the 5.5 times more intense, a tractor compared to threshold of hearing. So that's my I divided by I naught value, which is 10 to the 5.5. Okay, because we're comparing it to the reference. This is our reference level of intensity, barely discernible, right? Okay, think about this as having a base 10. Okay, so that equals 10 times, well, that's 5.5 if we convert this part to exponential form. So that's 55 decibels. Comparing the loudness of two sounds. So like the way we compare two earthquake intensities, we can compare the intensity of two sounds. Here's the formula. Decibel level 1 minus decibel level 2 equals 10 times the log of intensity 1 divided by intensity 2 when we're comparing two sounds. A jet engine at 20 meters is 145 decibels, while a power saw has an intensity of 120 decibels. How many times more intense is the jet engine than the power saw? So let's use our formula. A 145 jet engine minus the power saw 120, the intensity level or the decibel levels, equals 10 times log of I1 over I2. So we're comparing the two intensities. We want to know how many times more intense is the jet engine. Well, we're going to solve for the I1 over I2 value. Okay. So what do we get? We get 25 equals 10 times the log of I1 over I2. Okay, that's divide both sides by 10. I get 2.5 equals log of I1 over I2. Convert to exponential form, 10 to the 2.5 equals I1 over I2. If I solve for I1, I get I1 equals I2 times 10 to the 2.5. Bring it over here. I1 equals about 316 times I2. So jet engine is 316 times more intense than a power saw. The sound of Jisoo's farm tractor is 63 times more intense than the sound of Jenny's car. If the sound level of Jenny's car is 83 decibels, then what is the sound level of Jisoo's tractor? Wow, is Blackpink into farming? Maybe. Alright, dB decibel level 1 minus decibel level 2 equals 10 times the log of I1 over I2. Decibel level 1 minus 83 equals 10 times the log of, well, we said 63 times is the ratio of the comparison of the two intensities of the tractor, which is noisier than the car, or it's louder, right? The intensity of the noise is louder. Okay, so I got decibel level 1 equals 83 plus 10 log of 63. Decibel level 1 equals 83 plus 10 times, think of this as 83. Let me just do this piecemeal here. Let's see, log base 10 of 63. That's 10 times 1.799345. And let's round to the nearest whole decimal. So 83 plus That's 17.993405 plus 83. That's 100.9934 decibels, and rounded, that's 101 decibels. Okay.